2.64, part B, is a plane round trip from San Francisco to Chicago. It's 2,000 miles each way. That's delta x. That's a distance, a displacement, a separation between two positions. Wind is blowing 170 miles an hour from the west to the east. That sounds pretty fast, but up high in the atmosphere, these are called the prevailing winds, and 170 mile per hour prevailing wind, persistent from west to east across the continent, is not uncommon. So velocity of the wind relative to the Earth, 170 miles per hour. Now an airplane has, in my problem, it has a cruising speed. Airplanes fly through the wind, so the velocity of the plane relative to the wind is 600 miles per hour. How long for a round trip? All right. We do have a formula from class that the velocity of object A relative to object B is equal to the velocity of object A relative to the Earth minus the velocity of object B relative to the Earth. That's pretty formal. So if we say that first, so there's going to be two parts to this. There's going to be a time it takes to go from San Francisco to Chicago, and then a time from Chicago to San Francisco. So San Francisco to Chicago, part one. The velocity of the plane relative to the wind is going to be equal to the velocity of the plane relative to the Earth. And that's what the passengers care about. They don't care about how quickly the plane is flying through the air. They want to know how fast the plane is moving relative to the Earth, because the people are going from point to point on the Earth, minus the velocity of the wind relative to the Earth. So if we lay down an axis and call this positive in the x, and this negative in the x, then we could say that the velocity of the plane relative to the wind, and let's say the plane is going to be flying from San Francisco to Chicago. Plane flies faster than the wind. This is the velocity of the plane in the wind. The wind is pointing in the positive direction. This is going in the positive direction. So the velocity of the plane in the wind is 600 miles per hour relative to the wind. So the wind perceives the plane flying at 600 miles an hour in the direction that it's going. Velocity of the plane relative to the Earth, that's what we want to find out. How fast is it really moving across the continent? Velocity of the wind relative to the Earth is 170 miles per hour in the positive direction. So it's not surprising that if we add 170 to both sides, that the airplane is traveling very quickly relative to the Earth, and you can use a standard, a simple kinematic equation for, let's see, for distance in time, x final minus x final is equal to x initial plus velocity through time. You know the velocity, it's a constant, we've just calculated it. You know these two positions, the difference between them is delta x, 2,000 miles. You can figure out the time. The situation will be opposite the other way on the return trip. On the return trip, the wind is actually going opposite. I mean, the airplane is going opposite of the wind, and that's negative 600 miles per hour. So this will be a negative 600 miles per hour on the return trip. And the velocities, and the velocity of the plane relative to the Earth. So if this was a negative 600 miles an hour, so on part B, on the return journey, we have negative 600 miles per hour. That means going in the negative direction is equal to the velocity of the plane relative to the Earth minus 170 miles per hour. I'm now going to add 170 to both sides. This says that the 170, so that is 430, negative 430 miles per hour is equal to the velocity of the plane relative to the Earth. So negative means it's traveling from Chicago to San Francisco, and it's traveling slower, and it's going to cover, you can calculate how much time that takes using the same equation. Add them both up to calculate a round trip time. The disappointing part about the headwind, about the wind blowing, is that you gain time going one direction, you lose time going the other direction, and the time that you lose is greater than the time that you gain. So on a round journey, you're not better off with the wind blowing.